All right, we're back. We are Game 2005 in the fall 2019 semester at George Brown, and it's Game Physics, that's Lesson 12, and we're talking about basic collision detection. So I want to talk about a couple things today. One of them is Assignment 3 that's going to be given out. Right, so Assignment 3 is going to be due week 14. Again, it's Friday, December 6, 2019 at midnight. It'll be a group assignment again. One thing that I want you guys to do with this assignment is please do not create your own template. I know some people did that for assignment 2. I'm looking for you guys to keep assignment 3 with the template that I give you. All right, and I've given you the template up on Blackboard. I'll show you where that is in a second. More or less, you're going to be using this assignment, but you need to get your own textures and sound assets, to make an appropriate scene. So what will you be doing? You'll be using STL template to create a simple scene that includes a bouncing ball. That's just task 1, and a player-controlled brick. So the brick will move around, and use the appropriate collision detection and response techniques to solve the problem. So basically, what this is more of a collision detection thing. Or collision response thing, I mean. So the bouncing ball, it'll collide with the scene's boundaries, so it'll collide all the way around. It might have some initial velocity, so it's going to have something to start with. And what it should do is maintain its momentum when it hits the walls a little bit, but just there should be some little bit of loss. Okay? As momentum is lost, it'll continue to slow down, because every bounce will rob it of some energy. That's what's going to happen. And then in part B, what you're going to do is you're going to have this brick that you're going to control. The brick could be horizontal or vertical. It's up to you. And then, or it could be a different shape. It doesn't have to be like an elongated, kind of paddle shape like you would do in Brick Breaker, or a vertical kind of paddle like you would in something like Pong. But what you're going to do is move this brick around, and then your mouse is going to control this, and you're going to hit the bouncing ball with your brick and impart energy to the ball. So it's going to maintain its momentum, or gain momentum if you hit it hard enough, and it's going to continue to bounce and respond to the collisions that it's going to do in the entire scene. Now, there's nothing else you need to put here. Just it's going to collide with the boundaries, and of course the brick itself. If you want to challenge yourself, you could put additional items that the ball could bounce off of, different kind of platforms or ramps, but that's not required. So that's part 1. So it looks pretty easy, but really what I'm looking for here is momentum and to do it properly with physics, and the collision response is what I'm looking for here more than anything else. Part 2 is really all around, it's going to be a simple scene where it's raining bullets. So you got lots and lots of bullets coming down. And what's going to happen is these bullets, these 10 bullets I said, and again you can make 10 or more, but whatever number you decide on, it's going to be the same number the whole time. So you're not going to create bullets or instantiate bullets and then destroy them. What you're going to do actually is you're going to reuse them. And this part here is the tricky part. What we're going to be implementing next week, we're going to be talking about object pooling, and how that's an optimization pattern that you can use to reuse items in your video games. Right? So that's bullets being reused, okay, and with the object pooling pattern. So that's part A. Part B is your bullets will move down the screen at approximately 10 pixels per frame. The bullets will appear at the top of the screen randomly and at a random axis position, and then when they fall off the screen, they basically get reset. That's what happens, back into the pool. The player will control a sprite, and again you can control any avatar you want that has some kind of appealing texture. It could be a spaceship, it could be a plane, it could be something else. And then you may use mouse control or keyboard control for this one. And if the player's avatar, and I said ship here, gets hit by any bullet, an explosion sound clip will sound, and make sure that the explosion sounds only once per bullet. So we don't want multiple collisions per item. Okay, so this is assignment 3. The same restrictions are there for your submission. You can work within your teams. Each member should submit their student ID and so on Blackboard. Each assignment part should be presented. Now, it says in its own Visual Studio project. I know I spoke to people earlier and I said do it in one project. You could totally do that. You can make separate scenes for this. It's up to you. I would accept one project that has multiple scenes, or 2 projects. I would accept both in this case. And then finally, provide a GitHub link. I prefer a GitHub link over a zip archive as it's easier. However, make sure that your GitHub link works or your zip archive works, because I've gotten submissions in the past that are just a solution file or something insane. That's bad. Alright, so that's due December 6th, so a couple weeks away. It's not very far away. It's not a difficult one. But one of the keys is make sure that you're using this template, because the template that I'm giving you is going to be almost the exact same template that you're going to use on your final test, which is on week 15. Okay? Questions around assignment 3. Again, this is due 2 weeks from now. Alright, so we're moving on. What I want to do, just going to close some of this stuff off. What I want to do here is I want to move into the coding portion of our lab. And up on Blackboard, if you look on Blackboard here, I've included a couple things. 1, the PowerPoint from this week. 2, the assignment template with the template version 7. Please download this one if you want to follow along. So template version 7. As well as the Lab 5, which is AABB implementation using my template. That's what it is. Okay, so that's really all you have to do for this week to get your marks, participation marks in class. Let's make it work. So again, I'm going to go into the Visual Studio project. I've given you that file to download. And again, if I was going to go into our project files, you can see that I have this template version 7. I'm just going to extract the template here. And I'm going to call this collision. Where did I put it? Oh, here it is. I want to take this one and call it collision 3. You guys are the 3rd class today, so I'm going to cut this out, and we're going to put it up here. I don't need these ones. I already have them up online. It's the ones we've been working with before, so they can go away. And I don't need this V7. That can go away too. Alright, so collision 3 is the one that I want to work with. Yours will be called template version 7. I'm just going to launch this thing. So the garbage files have been removed, so there are no database files and all that stuff, or IPCH files that are part of the project. Remember that when you download this project, and if I go to my Solution Explorer, the first thing you should do is retarget your solution. So we're going to go to my solution, right click, and then retarget solution. And then you should test the solution the way it is. So those are the first things. So if you don't retarget the solution, it'll be for my Windows API, not yours, which would be bad. So then you want to test it in debug mode, because debug mode is the only run configuration I've created. Again, if you really want to, you can create other ones, but really not necessary for this demo. It's really just a template. It's not a game engine, to make you guys understand how to do collision detection and response. Same template we've used all semester. And it's just building right now. So hopefully that'll work in a few seconds. So please download this if you want to follow along. So at the end of today, what we're going to have, so right now we have this little template, and what you have is, as an example, if I press the backtick character, that's like the left, to the left of the 1 key, there's a backtick. It'll make it can toggle on and off my UI. That's what it does. And I have this little ship that just kind of sits here. So that's what you should have too. Alright, so let's talk about this. What I want to do first is I want to give that ship some movement. Remember that the way my project is set up, I'm using a scene class, and I'm inheriting from the scene class, and right now my default scene is called the start scene. So I'm going to bring up startscene.h as well as startscene.cpp. Let's take a look at the H file first, the header file. You can see right now that it's including scene.h, which is the superclass, label.h, which we're not using right now, as well as ship.h, which is the game object for the ship that we have in play. I have some lifecycle functions that I'm using, so draw, update, and start as an example, handle events. These are all functions that have been inherited from the superclass, the scene superclass. And then I have my ship, and so on. In my startScene.cpp, if I go to the, I'm just going to go to the start function for a second, just to define everything. In the start function, you can see that I'm just initializing my ship's position at 50-50. Let's move that so we can see it. We'll move that to 100, 100. That's the first change I want to make. I'm also setting the position of the ship here. Okay, so we're going to add other things here. I'm going to add 2 more items. We're going to instantiate a planet, and we're going to also instantiate a mine, a space mine. That's what it is. So space mine. Yay. Really exciting stuff. In my update function right now, if I go to my update function, I'm just going to go there. You can see that I've commented out the move function. Because before the move function was used for physics, it would use gravity and so on. I'm not going to use gravity for this example. So I'm going to put it back in. Let's put the move function back in. And I'm going to zip down to the move function itself, m_move. And you can see here that I have this acceleration. I'm just going to turn acceleration off for this example. And I'm just going to comment out the acceleration piece altogether, this piece. So now all you get is your position plus your velocity. Okay, that's by default. However, we want the velocity to change. Whenever I press the W, A, S, or D keys, I want the velocity to be added to the position of the ship in order for us to get our new position. In order for me to do this, I need to get some input, and I'm going to do that inside the handle input event. So if you go to handle events, you can see that in handle events, if I scroll down, I have some key down events that I'm listening to, and here are the few that I want to modify. So around line 89 or so, you're going to see these SDLK. So SDL, hey SDL, look at the key map for W. So the SDL W is what I'm looking at here. If I press W, S, A, or D, I'm going to do something. And what I want to do is I want to create a state, a movement state. I could have this movement work with Booleans. I could say that, okay, I'm moving to the right. So turn moving to the right on. Boolean is true. But that means that I have to have like 4 Booleans. That doesn't make any sense. So I'd rather use some kind of movement state tracking. But in order for me to use movement state, I need a structure. What is a good structure to kind of record state, if you will? What would you say that's a good structure? Yeah, what would that say? So what's the structure that I would use? What do you think is a good one? I've used it before. Well, an enum is what I'm thinking. So an enum. So there's 2 ways I could do the enum. I could put the enum within the ship class. And because it's only being used for the ship, we could do that. Or we can make the enum in a separate file. I'm going to choose to put the enum in a separate file. I'm going to go to my Solution Explorer here. And inside of my header files, filter, I'm going to right click here. I'm going to add a new item. And please make sure that the path, the location of the new item is not the default location. You got to change this by clicking Browse, and you're not going to be in here. You're going to go up 1 level to the SRC folder. That's where the location of your file should be stored. I'm going to click Select Folder, and then I'm going to change the header. Instead of a header file, I'm going to make this an enum, and it's going to be called Move State, capital M, capital S. And then click Add. Again, note the position of where it's going to be. So if not defined, and we're going to put in, if not defined, this thing called Move State. Then what I want to is, I want to define Move State. This is my guard, so I don't include this twice by accident. And if what I want to do here is, so I'm going to say defined and then it's underscore underscore move underscore state. Okay, that's what this does. So this little pattern here, what it does, it kind of prevents us from loading it in twice or using it twice. Okay, I want to call it an enum. It's going to be called move state. It needs to be put in this code block, and in my move state code block, right, I want to define several states. One of them is move up for the W button, right? A would be move left. S would be move down. And of course D would be move right. Which one am I missing? I'm missing one more. Idle. Absolutely. So I could go to move, I want to call it move idle. And I'm just using move idle just to make sure it's different than, we have other enums in here that are called idle, but I'm just going to make it move idle for now. Alright, so this is my enum. I'm going to save it. Excellent. And this is a great place to put this up on GitHub. But again, I'm using a previous project, and I want to change the remote that I'm having this project point to. So one way to do it would be to go to the, I'm just going to go to my File Explorer project again. Here it is. You can see I've got a .git folder. I could reinitialize Git and start everything again, but that doesn't make any sense. I just want to point to this folder again and change the remote that's being stored in. So again, I'm going to go to my command line. Here's my command line. It's the easiest way for me to do it. And I'm going to drag and drop this folder, which is collision 3. Let me try that again. Sorry, what?
Should we be doing it?
I'm doing it because I'm doing the GitHub, but if you want to do it, you can. It'll be your own GitHub though.
Right.
So here I'm just kind of zipping there, and once I'm in there, I can do Git Remote. And if I do Git Remote, you can see that I have a remote called Origin. That Origin remote points to my previous repository. I don't want this. I want it to point to a new repository. So I'm going to go Git Remote remove Origin. And if I was to, let's try that again. Not Git. Git Remote remove Origin. There we go. And now if I do Git Remote, you can see that there's no remotes anymore. It doesn't exist. So I want to make a new remote, but the way to do this is to go up on GitHub. So github.com/George Brown. And what I want to do here is I want to make a new repository, so new. Call it the same thing. So we're going to call it GAME2005 in the fall 2019 semester, and it's lesson 12. Okay. And then just save, create repository. This is going to create an empty container for me, which is good. And I only need these last two lines of code right here. So if I take these last two lines of code, copy them, Control-C, go back to my command line and right-click, it actually allows me to create a new remote and then push everything up to my new remote in GitHub. Alright, so now you'll have a brand new GitHub repo that has all the previous commits plus all my new commits from today. Alright? Again, there's different ways I could have done this. I could have made a branch, you know, whatever. But I want to keep these repos separate, so you can always just go to that repo. Here it is. You can see this comes from a repo for pathfinding for another course. Doesn't matter. I've been using the same thing. Let's modify this thing. If you ever want to change the README file, you can totally do that. So again, it's not for this one, but actually for GAME2005, which is Game Physics, and it's lesson 12. And we're doing actually simple collision detection today. And notice when I do this, I have to do a commit. So I'm going to commit my changes. Now this means that my repo is actually ahead of my files by one commit. So in order for me to catch up, there's two ways I can do it. I can do it through command line, or I can do it through Visual Studio. I'm going to do it through command line here. So I'm going to say git pull. And what git pull will do is it'll pull that extra README file into my project. Cool. Let's go back to my Visual Studio project. That was a bit of an aside. But here's my Visual Studio project. You can see that I'm on the master branch here. right? I'm ready to go. I can actually use Visual Studio from now on because I've updated my remote. Alright, so I want to add this. I want to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. You can see that I've changed these things, and I'm going to say that I added move state enum. That's what I did just now. I'm going to click Commit All, and I'm going to go to Home, Sync, and Push. And this will push my new changes up to the master branch. And to see that change, if I go here, go to my code, and if I refresh, you can see that I added move state enum is right here. So these are the folders that have been affected. Nice and easy. All right, so now that we've moved state enum, I can move in different directions. I can register these movements. What I want to do is in my start scene.h, I want to include that enum. So I'm going to say include move state. There it is. And what I also want to do is I want to keep track of my move state. So I'm going to say that move state m_move state, which actually will keep track of which move state I'm in. This kind of is the declaration for move state, but I need to set up an initialization for it as well. And I'm going to initialize my move state inside my start function in my start scene.cpp. So going back to start scene.cpp, I'm going to head to my start function, and I'm going to initialize my move state right here. Let's say m_move state. I'm going to make that equal to move idle. So by default, I'm not moving, right? If that makes sense. Now what I want to do is I want to detect when my buttons are pressed, and I'm going to change this default move state from move idle to whatever the other move states are. Okay, so I'm going to go back to my to the handle events function, scroll down to around line 89 again, and I'm going to do one of these. I'm going to say that, well, m_move state, well, that equals to the new move state. So if I'm going W, I'm going up, so move up. And if I'm going S, with the S key, I'm moving down, obviously. So move down. If I'm going A, I'm in the A direction, I'm going to move left. And then for D, I'm going to move right. So there's that change. This is where the states change. Now this is for key button down. So whenever I press the key down, one of these buttons, it's going to change the state. But what if I unpress it or I let it go? I want the state to go back to idle. Now there's a danger in doing this way, and I'll talk about it in a sec. So down around line 115 now, there are the opposite states, the key up states. And I'm just going to make this a little better. So I want to do the same thing. I want to do move state, but instead of move up, this should be move idle, right? Move idle. So when I stop pressing the keys, these states will all be idle. However, there's a problem here. Can anyone see what the problem might be if I left it like this? So again, key down, I move up, down, left, right, but only for different keys. And then if I key up, I'm moving, I'm stopping moving altogether. And if you can't see it, think about what switch case is. Switch case is like an if else. That means I can't do move up and move down at the same time. It won't accept that, right? I mean, not that it makes sense anyway. But let's suppose I want to do like top right movement. So I would do like move up, press the W key and the D key at the same time, but guess what? It only accepts one case. Either moving up is going to happen or moving right is going to happen, but not both. Luckily, SDL has a solution for this in that it pulls this asynchronously, which is good. It doesn't do one at a time. It doesn't matter which key you press first necessarily, as long as you keep both keys pressed. However, we need to interpret these presses in the move function. So if I go back now to the move function, in the move function, I want to change my velocity depending on which key is pressed. So I could do a switch case, but if I do a switch case here, that means there's only one case at a time. Maybe here what I want to do is I want to do an if statement. So I'm going to say if m underscore move state is equal to move up, then do something. Otherwise, if it's moved down, if it's moved left, if it's moved right, or if it's idle, do something else. So what happens to a velocity if it's moved up? Well, I can say that m underscore velocity then would be equal to a new GLM vec2 object. This is my GLM vec2, and it's going to be up, which means the x-axis is not going to be affected. M underscore velocity dot x is going to be maintained. So whatever it was before, we're going to leave it as is. And then what we're going to do is we're going to change the up direction. Well, up in video games in our frame is -1, and this will be 0. Sorry, -1. I'll be okay. There's no z-axis. So this is up movement, the negative movement, because remember that we draw from the top left corner, so we draw to the right and down. And this is going back up, so we're going to go negative up on the y-axis. All right, so we're going to take this same thing and copy it and put it in there. And now instead of moving up, we want to move down. And moving down means that we would make it positive on the y-axis. Let's do the other states. Just going to copy this and paste it so we can save time. Well, it's not going to be the y state that's maintained. Now it's going to be the x state. So when I move to the right, let's actually move to the left first. Move to the left. If I move to the left, then my x state is going to be -1 f. But this part here, I'm not going to affect the y, so this would be n underscore velocity dot y. Whatever the y was, we're going to plug back in here. Okay, so this is move left. Let's try moving right. So again, just like this, move right. Right, we're going to say that this will be positive and this doesn't change. And one more, hold on, move idle. Yes?
Is there a difference between having the velocity.y or .x before or after?
Yeah, because this is the x-axis here. So all I'm doing is copying the x-axis back in here, and this is the y-axis here, because I'm not moving on the y-axis, right? So moving right, I'm going to go towards the right. If I'm moving idle, well, I don't need to do this case, right? This case here, I mean, I shouldn't, but you'll see that I do need this one, so let's just grab this. Moving idle, what that means is that these values should be 0. So we'll say 0.0f, and then 0.0f. So this is the idle state, when you won't be moving at all. All right, cool. So now we have a velocity, and depending on which direction we're going in, we're going to change our velocity in that direction. And we're going to take that velocity and add it to the position, whatever that position initially was. Now you're going to see that this is quite slow, this movement, but let's try it out and see if it works. So again, I'm going to save it. I'm going to press Control-Shift-B first. Control-Shift-B will build my project without actually running it. And if there's any errors, then it'll come up and I can deal with them right now. If there's no errors, then I can go here and just run it in the next phase. Just waiting for the build to complete. You can see build succeeded. And now I can just run it, and we should see that I should be able to move my ship up, down, left, right, and even diagonal. Right? Should be able to do that too. Pretty simple movement at this point. Are you with me?
Mine didn't build.
Yours did not build. Okay, so. Right, so let's take a look at this. I'm going to put this up on GitHub, and then maybe you can check my GitHub compared to yours, and then see, or to your code, and see what the problem is. So here what I've done is I've given movement capability to my ship. So here in my Team Explorer, I'm going to say Home. I'm going to go to Changes. You can see all I've changed my start scene. Let's say Added Player Movement. Commit all, Home, Sync, and push, which should push everything up to GitHub. So you should have that now up online, my changes. So you see what I'm doing, and then you can compare my code to your code, make sure that we're in the same space. So check it out. The only thing I changed this time, this iteration, was just the start scene.h and the start scene.cpp files. Those are the two files I changed. It might be that the enum is in the wrong space because when you created it, you didn't put it in the src folder. src. Okay, make sure, 'cause sometimes it doesn't go there. By default, it defaults back to the template or something else. All right, so this is where we're at right now. And what I want to do at this stage is, now that I've got everything moving, I want to describe the collision manager and how it works. So I've given you guys a collision manager, and this happened from last semester. Let's talk about this. There's two files for this one. There's collisionmanager.h, and there's also collisionmanager.cpp, those two files. Let's take a look at collisionmanager.h. What it does is, I've given you 4 different collision detection tools. One of them is square distance, and the other one that we're going to use today is square radius check, or like a circle check, basically. So, question for you: why squared? We talked about this in lecture on Tuesday. Why do I want to square my distance? Why not just get a distance? Why not do a distance check every frame? Well, I got to do with any kind of collision check is going to check every frame anyway. But why not a distance check? Why a squared distance check? I talked about this as an optimization thing. So remember that whenever I do Pythagorean distance, right, or Euclidean distance, if you will, I need to use square root. Square root checking every single frame multiple times is really computationally expensive. So I want to avoid square root use, and so I use squared distance and squared radius check. Okay? Let's take a look at the squared distance function. So I'm going to go here and go to definition, or the and when I go to the definition, you can see that the squared distance is defined as, I get 2 vectors, vector 1, a point 1, and a point 2. These 2 points, I take the components x from P2, so point 2.x minus it from point 1.x, I get an integer scalar. I do the same thing with y's, and I get the differences of x's and differences of y's, and then my result is the squares of those 2 values. And this is just one step removed. If I put a square root around this thing, right, the square root of this, then you would have just a regular distance check. Here it's a squared distance because I haven't square rooted it. Okay? So that's this squared distance formula. Then I do squared radius check. Squared radius check actually uses squared distance. It says, okay, so I'm going to get these 2 points from game object number 1 and game object number 2. They have position functions. We have a getter for the position, get position, and the get position returns some kind of GLM vec2 object with x and y coordinates. Okay. Also, one thing is that game objects, and that's maybe I created a bunch of game objects last time. Under the game object itself, here's gameObject.cpp and gameObject.h. You can see that gameObject.h has the following properties. It has, or the following public properties: get position, get rotation, get scale, get velocity, get width, get height. All these things are available in my game object superclass, right? So this is good news, because this way I can get things like, hey, I want to get the height of my object 1. I want to get the height of my object 2, and I want to multiply it by 0.5. So half the height and half the height of the other object, add them together, which is like half radius. That's half the radius of each of the objects. That's what this is. If the height was the same size as the width, and in this case they are. So if that's true, then what I want to do is I want to say, take the distance between P1 and P2, the centers of the objects. If that distance, the squared distance, is less than the squared half heights, right, which is your radius squared. So if the squared distance is less than the radius squared, then we know the object is colliding. I also have a check on line 23 which says, okay, well what if object 2 is already colliding? I don't want to collide it again. If it's already in collision state, leave it there. If it's not in collision state, then I want to take object 2's setIsColliding method and set it to true. And what this would do is set the collision state to true for the game object number 2. And then I also want to use this switch case to switch between which type of object. Is it a planet? Is it a mine? Because all objects have a type. And if you notice, I go back to the game object superclass, you can see that these are the different types of objects I've defined. You can also define other ones. Ship, target, planet, mine, tile, and a bunch of other ones. You can make as many of these types as you want. Here I'm just looking for 2, planet and mine. If I collide with the planet, then I want to make a little sound that says yay, and maybe I want to output to the console to say collision with planet. And if I collide with a mine, I'm going to say, I'm going to make a thunder sound, like an explosion sound, and then collision with mine. So if I collide with a mine, that would be bad. Okay? You're going to see also that there's a problem with this because I've never loaded the yay or the thunder sounds in. So we're not going to have sound in the beginning. We're going to get that after. So this little function, this little squared radius check, it takes 2 objects, gets the squared distance, and compares them with the squared radius. And if the squared distance is less than the squared radius, then I have a collision. And I only want to collide once. However, what's going to stop me from being in collision state? Right now, the way I've written this, nothing. I need to go down to the second last curly brace here inside this function, and I need to put an else statement. So this is on line 44 around. And so I say, okay, well, what this is saying is, okay, if this criteria meets, so I know that the squared distance is less than the squared radius, if that's true, then what I really want to do down here is say, well, that's a collision. But if it's not true, I can say that it's not a collision. So I can say that object 2 and then is colliding, and I want to say that set is colliding to false. So this only happens if my collision check fails. If that makes sense. I also want to return false at this step. So I want to say that return false. So if I come to this point, I want to return false because this is also a false ending, right? Remember, each of the branches have to come to an end at some point, and so I have to return I'm testing for this, and I can return a boolean, and I'm returning false if I get to this. I was not able to collide. Alright, so that is your collision manager. Well, how do I use my collision manager? One thing to note is my collision manager is using static functions. So I don't have to instantiate a type of collision manager. I just have to say collision manager dot, and then whatever or dash, if you will, and whatever the thing I want to test is. The collision manager itself, right, is not a it's not a singleton, but it's the use of static functions in a static class. So not object oriented in this case. So how do I use it? Well, if I need to use it in my start scene. So if I go to my start scene.cpp, and if I scroll down to the update function, here's my update function. I want to do a collision check every frame between the ship and the other objects. But I don't have any other objects yet. So let's get them. So in my start scene.h, I want to include 2 more objects. So I want to include 2 objects. One of the objects I want to include is my planet object. And I also want to include my mine object. So I got a planet and a mine that I just included. I also, if I want to use the collision manager, I need to include that. And I know I want to make sound, so I'm going to probably need the sound manager as well. So those are all the things I need. So I just included 4 more includes. Okay? Are you with me? 4 more includes. Alright, great. So now that I've got these 4 includes in there, and I've got my planet in my mine, I've got to declare and instantiate planet in mine first. So I'm going to scroll down to this area. This kind of is like ship stuff. So I can say that this is ship stuff. And down in here, this could be planet stuff. I don't have that yet. And maybe another area that's like mine stuff. Now, stuff is a weird word, but I'm just using it so I can kind of separate between my ship configs and my other configurations. Okay, planet. Let's instantiate or declare a planet. I'm going to say that planet star, which means pointer, m_p planet. I declare it as a pointer. Do the same thing with mine. So mine, pointer, m_p mine. There we go. So those 2 things. So now I've declared these objects, but I haven't instantiated them yet. To instantiate them, I need to go into the startScene.cpp file inside of the start function. So I'm going to go to my start function, and down in here where I said instantiate a planet and instantiate a space mine, I can do it in here. So I can say that to instantiate a planet, it's m_p planet is equal to a new keyword, planet. I use the new keyword to indicate that I'm allocating memory as a pointer on the heap. Okay, going down here, m_p mine is equal to a new mine. And this instantiates the planet and mine objects. Now, these are never going to show up unless I access another lifecycle function, which is the draw function. So here, I instantiate them inside the start function of the start scene, but then I've got to draw them. So I'm going to go back to the draw function, and in the draw function I'm going to put those 2 things in to draw. So m_p, again planet, I'm going to make sure that that's drawn every frame. I'm also going to draw the mine, so m_p mine, that's also going to be drawn. Okay, so this is in the draw lifecycle function that I made. So I draw the ship, I draw the planet, I draw the mine. Those are those things do. And I forgot to do something. I'm going to go back up in a second. But the next one is, let's update them. So typically the other lifecycle function I like to go to is the update function. So here I'm going to go m_p planet. I want to update that. And m_p mine. I want to call update on that too. There we go. So ship, planet, mine. One thing I forgot is in the start function. If I go back to the start function, yeah, sure, I made a planet, but the default is 0, 0. I want to position it, so I want to change the position of the planet. It's going to look like this, m_p planet, and then it's going to be set position, which is in a new GLM vec2 object, where I'm going to say that the position of the planet is going to be at 200 and then 100. So it's kind of to the right of my spaceship by default. And I'm also going to do the same trick for mine. I'm going to say, well, the mine I want it to be slightly lower. So I'm going to say that I want to set the position of the mine to 200, 200. So kind of diagonally across from the planet, or sorry, from the ship. So this instantiate this positions for both. Are you with me? Okay, now that I have this is a good place to test. Do these things show up on my screen? So I'm going to run this thing. I should see planet, ship, and mine. And I should see them in the right order. So the ship should be on the left. To the right of that should be the planet. And to below the planet should be the mine. That's how it should look. Let's wait till this is done. And there you have it. Ship, planet, mine. Okay, pretty simple. So here's what I want to do. When I march this ship over from here, and I make it go towards the mine, towards the planet, when it collides with the planet, I want to register a collision. When I go down here and I collide with the mine, I want it to register a position. By the way, I'm thinking this movement pattern for the ship is pretty slow. I want to need some kind of factor to move the ship faster. So while I'm thinking about that, let's just make it happen. I'm going to go back to my start scene.h, and in my ship stuff, I'm going to add a speed factor. I'm going to call this a new GLM vec2 object, which I'm going to call m_speed factor. Speed factor is just going to keep track of my speed factor, and I can change these numbers later, but I want it to be a variable and not a fixed value so that I can adjust this as I need. So I'm going to go back to my start scene.cpp and then go into my start function again. Here's my start function. And what I want to do is under move state, I want to say that m_speed factor is equal to a new GLM vec2 object that's going to be 2.0f and 2.0f. And what this means is it's going to be twice as fast now if I take my speed factor and multiply it by my velocity. Now this is a speed factor, but in order for me to make the velocity faster, I need to go to my move function. So I'm going to go to m_move. And in the move function, what I'm going to do is I'm going to scroll down to where it says velocity, and I'm going to multiply my velocity vector by my speed factor vector. Speed factor. And now we're going to have scaling. This vector is going to actually move a little faster because of my speed. So to test this, let's run it. To test this, now it should be twice as fast as what I had before. Well, based on, I'm just positioning it twice as far. So let's see how this looks. It should still look fairly smooth the way it works. Okay, so again, you can see now that it's a bit more responsive than it was before. Cool. So I've got the motion, and I instantiated a planet and a mine. Let's put that up on GitHub. So Solution Explorer. Let's actually go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. You can see that I've changed Collision Manager as well as Start Scene, and I'm going to say that added planet and ship objects to the start scene. Okay, and then commit all, and then sync and push. And that's going to push it up on GitHub. So if you ever want to check GitHub as I'm going, you can totally check all the code that I put in, and the changes are up on GitHub. Cool, so I have motion, but now I need detection. And I'm going to detect it inside of the update function. So the way this works again is I'm going to go here, I'm going to go to update, and after I update the items, I want to start using my collision manager. So the way the collision manager works is like this. Hey, collision manager. And then what I want to do is in the collision manager namespace, I want to use the squared radius check. And I want to pass in object 1 and object 2 to test. The first object is the ship. Oops. And the second object is the planet. That's all I need. If I pass this in, it will tell me if I've got a collision check between ship and planet. Let's do it again though for the ship and the mine. There we go. So now the mine is going to be checked. Ship, planet, ship, mine. I'm checking those two interactions. And when I run this now, we're not going to hear sound, but what we're going to see is my output over here is going to show that I've collided. So let's do this. I'm going to move this to the right, and you can see, oh, there's my collision. I also see a bit of an error, but you can see I can come back and forth, but I only collide once. I don't collide multiple times. Same thing with the mine. So I go in here, I collide with the mine only once. I don't collide with the mine multiple times. And even if I go here, you can see that I can collide with different things, planet and mine, and they don't overlap. Even if I sit in here inside the planet, it's not going to continuously collide. We don't want that to happen. Alright, great. So now that I have this working, I want to get my sound working. But in order for me to know how that works, I need to check my files a little bit. Let's check my project. So my sound manager lives in a soundmanager.h file as well as in a soundmanager.cpp file. Here they are. Soundmanager.h, what it says is, hey, let's use the mixer.h library. And then as I scroll down, I have this little embedded enum, which is called sound type. Sound type specifies two things: sound music or sound special effects. We're going to use sound special effects. And you can see that it has two functions that are three functions that I use: a load function, a play sound function, and a play music function. We care about the load function right now because the play sound is only going to happen inside of the collision manager, and it's already happening. It's just not playing anything because there is no sound that I've loaded. So I've got to call the load function. In order for me to do that, I'm going to go back to the startScene.h. You can see that my soundmanager.h has already been added, so I should have access to it. But in my startScene.cpp, in my start function, here's my start function, I want to, let's do it at the top, I want to initialize my sounds. I'm going to load them in. So the way this looks is this: I'm going to say that the sound manager, : instance, we're using the singleton pattern, and I want to load a file from / assets / audio / and then it's going to be the yay sound, so it's going to be yay.og, and then in the next argument it's going to be the friendly name for the sound, which is yay, followed by the sound type, which is sound special effects. And there you go. That is the line that we need to load a sound asset into my sound manager. This line. I want to do it again, and not just for yay, but for thunder. So I'm going to kind of copy this whole thing, copy it, go down here and paste it, and now I'm going to load, but instead of loading yay, I'm going to load thunder, and I'm going to change the friendly name from yay to thunder. Sorry, you know what I'll do for you? I'll put them on separate lines. So here. So it looks like this. So here's my configuration. There we go. Is that easier for you to read? Okay, so I've got my yay sound and my thunder sound. How the heck did I know to go to one up, assets, and audio? Did I just think it up? Well, I've done it before, but let me show you why this is happening. So when I go to my folders, in my collision 3, I know that my collision manager lives, and so does my other files, inside of my source folder. These are all the files, right? So it means I have to go one up. One up goes to this folder. And then I can see that I have an assets folder. So I go one up, and that's the : that's this part, : that's one up. And then I'm going to go into my assets folder, assets, and then into audio, and then choose my file, yay.og. That's og vorbis. Same thing with thunder, thunder.og. And once I've got this loaded in, now everything else in my project should be able to use my sound manager. Let's see if that works. So I'm going to press play, and now if I collide, I should be able to hear my sounds being made when I collide with my other objects. Let's see.
Yay.
Right? And then if I click with this one, and you can see that I have different sounds.
Yay.
Right? Every time I collide. So kind of very simple collision detection with some funny sounds. So that's what you should have right now. Any questions around what I did? So again, I used the collision manager. The collision manager, which is a separate class. It uses static functions, so it's not a singleton. This is another way of doing it. And the static functions, what they do is there's two of them: squared distance and squared radius check. Okay. Okay. Challenge time. Challenge time. For you, what I want you to do is I want you to implement a new function for AABB checking. So access line bounding box. This is due tomorrow at midnight. So here's your to-do. You need to write a new function. So it's going to be called static bool. Here's how we're going to start it. It's going to be AABB check. And then you're going to pass in the game objects just like these ones. So that's going to be your header, right, for AABB check. Actually, just write it. And then what I can do is if I click onto it, and if I go to my light bulb here, it allows me to, let's try that again. What I want to do is I want to create my definition, which does it in my collision manager.cpp. I'm going to close this one off. And in my collision manager.cpp at the bottom now, I have this empty declaration, right? Which is wherever it was put actually. Where is it? Here it is. On line 54 in my case, I got this empty declaration for my AABB check. What I want to do is here's my to-do. I want to write the AABB check algorithm in here, right? And that can be found on my last PowerPoint slide. On Tuesday, I gave you the code for this in Pseudocode. Here's the Pseudocode. I want you to take this code here, primarily this code, and I want you to place it back in here, right? You're going to take object 1 and object 2. What you don't need is rectangles. You don't need these rectangles because guess what? Object 1.getPosition.x gives you this. Object 1.getWidth gives you this. So you don't need rectangles. You already have them, right? So you need to rewrite this part. This is step 1. Part 1, rewrite this. Okay? 2, in your startScene.h or .cpp, in the update function, let's go to the update function, where I have these checks, let's comment them out. And what I'm looking for you guys to do for your lab is the following. To do. I want to call the collision manager, but instead of calling squared radius check, you're going to call AABB check, and you're going to pass in m_ship and planet. You're going to replace the above function, this one here, my squared radius, with an AABB check, this thing. I'm going to do this a couple of times, one for planet and ship, and the other one for ship and mine. Okay? Great. I want to put this up on GitHub now, so you have this exact code. So I'm going to go to Team Explorer. I'm going to go to Home, Changes. You can see that I've changed Collision Manager in my start scene. I'm going to say that I added sounds to the simulation. Commit all. And then I'm going to go sync and push. So you should have all my code now. So where do you find instructions for your lab? Well, if you go up online again, if you go to week 12, you can see that there's lab 5 instructions. Here's lab 5. It's a bonus. AABB implementation. Using the template provided in class, complete the AABB check function in the collision manager. And it tells you what to do. So please follow this instruction. This is due tomorrow at midnight for bonus marks. So please get this done. It's fairly simple. You can probably get it done before you leave today. Now, here's the challenge. The challenge is you should be able to complete this step in 10 minutes or less. If you can't do this little algorithm given the code, remember, because you already have the code here, given this code and the structure that I've given you, if you can't complete it in 10 minutes or less, you need to practice, because on the test I'm going to give you several little tasks to do that are going to use my template. So you need to know how to use it. It's not difficult to do. Questions around Lab 5. Lab 5 is due tomorrow for bonus marks. I also, in this lesson, covered Assignment 3, which is due December 6th. That's 2 short weeks from now. You could do it in the same project teams you have today, all right? Or if you'd like to work on your own, you need to let me know, right? Otherwise, you need to check that out. Alright, so please take a look at that. I posted the document for assignment 3 up online. So if you look online, and if you go to assignments, you can see that the assignment 3 Dropbox is here. It's here. So please take a look at that. That's live and open, and it's due Friday, December 6th. Otherwise, that's it for me for today. Your task is to put this up on GitHub, right? I will stop recording at this point, and then if you have any questions, feel free to DM me on Discord, or people that are in class, you can ask me in class, and I'll try and help you out. All right? Let me just stop recording this now.